All right, so let's again look at some past paper questions. Well, just follow the instructions. The derivative of e to the x sine 3x plus 3. So obviously the 3 is a constant. E to the x sine 3x, well, that's a product rule. Two distinct functions there. So so my product rule is derivative of the first, so 3e to the 3x times the second, plus the derivative of the second, so the derivative of sine 3x is 3 cos 3x. Probably for consistency, that should be a 3, times the first, which is e to the 3x. So my derivative, if I bring it all together, 3e to the 3x sine 3x plus 3e to the 3x cos 3x. Now, part B, hence, keyword, massive word, find an antiderivative of. So if I just expand this bracket here, this term over here, that's what I'm looking for. I'm looking for the antiderivative of that expression. All right, so we were told to start with the derivative we've just worked out, which I've done. So you can see there in black, dy dx equals the derivative from part A. So if I integrate both sides with respect to x, well, the antiderivative of the derivative is just y on the left-hand side. Again, probably for continuity, maybe I could have written that as a black y. And I'm not going to try and resolve this right-hand side, okay? But if I look at this right-hand side, these expressions here are 2/3 of the derivative that we're trying to find in our solution. The only thing that's missing is the 3 sine 3x dx. So what I've done is I add the 3 sine 3x dx to both sides. We have equality. So now all of a sudden the right-hand side is exactly the answer we're looking for. Okay, so that's the expression we're trying to solve. It's on the right-hand side, so it must equal the left-hand side. So here, my answer must be y plus the integral of 3 sine 3x dx. And if I evaluate that, y in blue from the question is just e to the x sine 3x plus 3, and the antiderivative of 3 sine 3x is 1 on k, or negative 1 on k cos 3x. So the 1/3 and 3 cancel to leave me with negative cos 3x there. Okay, so it's exactly the same process that we've been practicing. Right, find my derivative, integrate both sides, manipulate to get the expression that we need. We do something similar for question 2. So first things first, write down a rule for function. So we've written it instead as a composite function, isn't it? So the internal function, if you like, is cos 2x. The external function is natural log of x. So f of x is the outside function. So f of x, well, actually, there's a little error there, isn't it? We really should write, uh, f of x is equal to natural log of x, not y. Okay, so that's what the f of x function is. So find the derivative of f of g of x. So we have a chain rule situation. So let's put u equal, so there's two ways we can do it. The long way, put u equal to cos 2x, u dash is negative 2 sine 2x, y equal to log x, y equal to natural log of u, y dash is 1 on u. And so then our derivative is a product of the functions, yeah? Or we remember that the derivative of natural log of x is f dash of x over f of x. So the derivative of cos 2x, negative 2 sine 2x, over the function, which is cos 2x. Simplify and group, I get negative 2 tan x, all right? And let's face it, a lot of questions you sort of sometimes think, oh, have I done it right? Well, the next part suggests that we're on the right track because we want to use that answer to work out an antiderivative of tan 2x, all right? So let's use the previous answer. So in black, dy dx is equal to negative 2 tan 2x from the previous part. Again, if I integrate both sides, the antiderivative of the derivative is just the original function y. No, I brought the little -2 out the front because now I've got -2 times the integral of tan 2x dx. That's the expression I'm trying to get an answer for. That's what the question wants me to find. So clearly, if I divide both sides by -2, let's drop the negative off there somewhere. If I divide both sides by -2, I get -y on 2 is equal to the antiderivative of tan 2x dx. So what was y? Y from the question is the natural log of cos 2x, and we multiply that by -1/2, we get an answer. So -1/2 natural log of cos 2x is equal to the antiderivative of tan 2x dx. Done. The rule of our formula sheet. Let's go. All right, this one is just relatively straightforward question, probably part A of a question that goes on to get something else needs to be done. Find the antiderivative of the function y equals 2x plus 3 to the 5. So we add 1 to the power, divide by the power, so the power becomes 6, divide by 6, then divide by the derivative of tan of 2x plus 3, which of course is 2. So I end up with 1 on 12 outside of 2x plus 3 to the power of 6 plus some constant c. More than likely, we then had to use that antiderivative to answer a question of some kind. Question 4, another one of those by inspections. Integration by recognition, I guess. Now we're told f of x is equal to, so we've been given f of x already. I don't want to use that one. There's my f of x. Here's my derivative expression there. So given that information, find an antiderivative of x over square root of 1 minus x. So this is what I'm looking for. That's what the question's asking me to find. The antiderivative of x over the square root of 1 minus x. What information do I have? All right, so in black, I do know that dy dx is equal to minus a half of x over 1 minus x, which is this section here, plus the square root of 1 minus x. So that's what the question has told me. So now if I integrate both sides with respect to x, hopefully getting used to this process, the integral of dy dx dx is just leave me with y. Now, I'm going to subtract that expression across. So I'm going to bring that over here. So y minus the integral of 1 minus x to the power of a half dx is equal to negative a half square root of x over the square root of 1 minus x dx. Hopefully you can see here that that's the expression I'm looking for. So I'm getting closer. So next line, y can stay as y for now. The antiderivative of this integral here, add 1 to the power, divide by the power. Oh, there's a mistake there, Mr. Gale. Let's pick that up. Times, whoops, times -1. So let's put a -1 in there as well. So that makes that from the derivative here equals negative a half of x over the square root of 1 minus x dx. So what does that mean? So I'm going to get a positive 2/3 square root of 1 minus x to the 3 on 2 equals negative a half of x times 1 minus x. If I multiply both sides by -2 now, I get -2 times y. That's my y expression. And we're going to change that positive. I'm going to change that positive back to a negative because -2 times positive 2/3 is -4/3. 1 minus x to the 3 on 2 equals, what happened to my integral sign? And so that right-hand side is now the expression I was looking for, and that's equal to the left-hand side. So there's an expression there. Now, look, it is possible, that's x to the power of a half here. I could possibly take 1 minus x to the power of a half out the front, and that leaves me with -4 on 3 times 1 minus x minus 2x. And we could group those terms together. What's that going to give me? Negative 4/3 plus 4/3 x minus 6x on 3. 1 minus x to the half. 4/3 of x minus, that's minus 2 on 3x plus 2. How does that look? If I expand that, I get negative 2 on 3x, which is that expression, and I get negative 2/3 times 2, which is negative 4/3. So it could possibly simplify to the half x plus 2. Okay, but if we're not given instruction as to how simple it needs to be, no issue with that answer, just up there as it is. All right. Next question, square root of x, root x plus e to the 2x. Again, let's write everything in the power that they are, x to the half, e to the 2x, antiderivatives. Integrate each term on its own. Add 1 to the power and divide, plus 1 on k, e to the kx, plus some constant c. So 1 over 3 on 2 is 2 on 3, x to the 3 on 2, plus a half e to the 2x plus c. So a fairly straightforward sort of question. Part B, here's our derivative, and now we need to get the original function. So again, we know the derivative is equal to sine 3x, so if I anti-differentiate both sides, I get f of x is equal to the integral of sine 3x dx. Antiderivative of sine is negative cos, so we get 1/3, negative 1 on 3 cos 3x plus c. I've got an initial condition here, so if I put, don't forget that's y, that's x, so 4/3 is equal to minus 1/3 cos of 3 pi plus c. So where's cos of 3 pi? So it's 0, 1, 2, 3 pi there, where cos is negative 1. So minus 1/3 times negative 1 is positive 1/3. Subtract that from both sides, I'll get c is equal to 1. And my function there was 1/3 cos 3x. Yeah. So find an antiderivative, again, probably part of a question that wasn't quite finished. Find the antiderivative of sine 3x minus 1. And we get negative 1/3 cos 3x minus 1. So there's a series of typical sort of short answer questions.